getting to the point where we really need to jump into our program. And the reason we're here tonight is to hear Dr. Aaron Reardon with her presentation. And I don't want to take too much time with introducing her because I did send you her bio and a link to her information because she is a partner up at Tumamoc at the Desert Lab. And Erin works at the intersection of ecology and climate and conservation. And I guess I'll stop there. Erin, you can fill in the rest of those blanks because I think we want to jump on your program now. And welcome. We are so glad you are here.
Oh, well, thanks so much, Trika, and thank you everybody that's here. I've been really loving these steward trainings, and it's so great to finally get to talk to all of you and share a bit about what I do and have some conversation. So I'm really looking forward to this evening. I'll go ahead and share my screen.
And while she's doing that, Erin and I discussed this earlier. We will have a time for Q&A and discussion at the end of her program. But if you did anything really pressing, a comment, a question, you can use the chat box. You can interrupt us. I'm running a view on the chat box and any hand raising. But if I miss it, you can just speak up, but we'll at the end.
Great. Well, thanks, Trika. Is everybody seeing my screen okay?
Looks good.
All right, thank you. I'll just make sure I have a little pointer prep too. So today I'm going to talk about a research project, and it's related to a research initiative that we're developing here at Tumamoc Hill that's centered around trying to create a resilient food future for our deserts and arid lands in North America, which we're calling Aridamerica. And this is a real collaborative project. We are bringing in expertise from all sorts of disciplines. Gary has been heading the effort, but we have individuals with backgrounds in public health and ecophysiology, in agrovoltaics, which I'll talk about a little bit more. We've got ecologists and botanists, people that are ethnobotanists. So we're really just trying to draw on a broad base of knowledge to come up with some out-of-the-box solutions for how we're going to be able to feed ourselves and do so in a way that is sustainable and actually can help support the environment and local livelihoods and community health moving into the future. So with that, I think I'll just maybe start with climate change, since that was really the big motivator for this project. And I think here in the desert, we are really feeling some of these shifts in climate. Just in the last 20 years, we've had extended drought. And one of the things that is different about this drought is, the warmer temperatures that we're getting with climate change, it's actually making the drought much, much worse. So in arid regions, we're no stranger to periodic droughts. I'm sure your parents have mentioned periods, if they're from Tucson, where we've had droughts, and local producers and farmers have been able to ride out some of those droughts. But if we could put our current 20-year drought in the context of a longer history, we can see that it's among the worst mega droughts that we've had in 1,200 years. And we've gotten some of that information from tree rings. So on a side note, I spend part of my time working in the tree ring lab here at the University of Arizona, and the other part of my time diving into topics about food and climate change and ecology at Tumamoc Hill. And so what's really concerning is these sorts of patterns are a glimpse into what we're going to see in the future. We expect continued warming if we continue to have these high greenhouse gas emissions. And we're also expecting more variability in things like precipitation and other sorts of extreme events, whether it's extreme heat waves, extreme droughts, or just right now with Texas and much of the US in this really cold snap, there's some signs that that's related to climate change, that it's kind of the really big differences in the temperatures at the poles and that really cold Arctic temperatures that help keep the jet stream in a tight streamline further north. But as you start get warming in the Arctic, then there's some tendency then to get more of a wobble in your jet stream, and all of a sudden we get this cold air coming down much farther south. And it seems a little bit weird to think that extreme cold events are related to climate change, since we spend so much time thinking about global warming. But there's a lot of variability and things that are out of what we've experienced in the past that we're expecting as we go forwards, which can make it really challenging to try to come up with solutions, and we have to get more creative, and there's an urgency. And so what's a really big concern here in the Southwest and Northwestern Mexico is we're already really, really hot and dry. And in some places at the extremes of what we can do when it comes to food production, and we're seeing some of our water resources already dwindling. And if we look at this map here from the drought monitor, we can see, if we zoom in on Arizona, that 3/4 of the state, or a little bit more than that as of December, before we got any of our winter rains, was in this really extreme, exceptional drought category. And that's when we start seeing some really big impacts on human health and also our crops. And so, we start getting into temperatures where our commercial crops, they can't really successfully flower and fruit. And we see, really big impacts then on our ability to have some food security. There's also a really big health toll of climate change, and that's starting to come out. And so some things that we're seeing are increases in heat-related illnesses and deaths, but there's also a link with climate change and chronic illness. So we can see that this additional environmental stress is really exacerbating certain chronic illnesses. An example of that is diabetes. And here in Arizona, we know that in some of our lower income populations, especially in our Latinx and indigenous communities, there's a really high occurrence of diabetes, and that's in part related to food insecurity issues and food security issues. And so we can think about how, as climate changes, it's not only exacerbating a lot of health problems that we have, but then there's this combination with challenges of perhaps exacerbating food insecurity. And one big problem we have is, if we think about this, the large scale industrialized agriculture that feeds much of the US, that's really exacerbating climate change. And so a lot of our greenhouse emissions are coming from these industrialized agricultural food systems. And these systems are also degrading kind of the environmental basis for food production. And so we see lots of land that's being cleared for agricultural uses. We have a ton of our freshwater resources, which are going towards agriculture. And as we start getting more frequent droughts, we're going to have less water resources to put into food, and we'll have more and more water shortages. We also see other sorts of impacts on biodiversity here in the marine and freshwater world of eutrophication. And so there's some really big environmental impacts. There's a really close tie between the way we produce food and environmental health and climate change. There's also some ties between the way we produce food and kind of the vulnerability and resilience of our food systems. And this is something that we're starting to really see strong examples of with the COVID-19 pandemic. So when we have these really globalized food systems where you're depending on the labor and supplies and fuel from really distant sources, all of a sudden, if there's a disruption in one part of that chain, then you, no matter where you're at in the chain, are going to feel that effect. And with the COVID-19 pandemic, we're seeing big disruptions across all parts of the chain, and we're really starting to see how those are playing out and making, seeing breakdowns in getting food from fields out to consumers. Seeing earlier in the pandemic, there was issues with food shortages and food access. And, we can really just see how these really globalized dominant food systems are breaking down under these pressures. And climate change is another kind of stressor, just like the pandemic, that is going to create vulnerabilities and potentially exacerbate some of the issues that we have when it comes to worrying about food security. One of the other challenges that we have is, even though in recent years we've really increased our capacity to produce food, is we still have a lot of nutrition related illnesses. And so this graph has a bit going on, but if we're looking at like high blood pressure and blood sugar, pollution, other diet related issues, these are really prevalent in the US and in our society. And there's also, some links to food insecurity as well. And just to circle back to COVID-19 here in Arizona, we can see that we are seeing a big increase in the food insecurity with the pandemic. And so this graph here with the different colors is showing this blue color is food insecurity pre-pandemic. And then the tan color is that's food security pre-pandemic. The tan color is food insecurity with the pandemic. And then the kind of dark brown reddish color is those that had food insecurity pre-pandemic. And so it's about right now, statewide, 1 in 3 households that's struggling with food insecurity right now. And so all of this is to say that, we're in a bind, quite frankly. We're seeing, really big impacts of climate change and other kind of food system disruptors that are impacting our human health and our land health. And we really need to start coming up with solutions that can address these really compound and interwoven stressors. And that's really been the big motivation for this project, is we are seeing the glimpse just, in the last 20 years of what the future looks like. And we need to start coming up with solutions that, are more sustainable and can help support and rehabilitate the environment, and can address some of these issues that we have with human health, and also the loss of livelihoods that we're seeing. So as we're thinking about what we can learn from the deserts and trying to come up with a new model of how we can produce food, one person I wanted to mention is Richard Felger. And so Richard Felger is a dear friend and was a mentor to many, including Ben Wilder. And he really saw the potential of desert adapted plants for agriculture early on. And so he and Gary as well had work, in the late 70s and 80s that were looking into desert plants and desert crops as our crops for the future. And he has a quote that I love, and that is, fit the crop to the land, not the land to the crop. So much of what we do, in recent years has been remaking the whole environment to fit a small subset of crops. And that is just simply not sustainable. And so we are turning with this project and this research initiative to our Sonoran Desert ecosystems to find inspiration for a new path forward. And we want this to be holistic, but also pragmatic. And we want to be addressing kind of the agro-ecological health in our ecosystem services, human health, and also help build community well-being and kind of local livelihoods. And I shared this paper with Trika, so it's part of what I'll be talking about today. And this was a conceptual paper with led by Gary Nabhan, but with a whole slew of co-authors with different backgrounds that we're trying to create this conceptual model of, all right, so, what would be the plants for our new model of agriculture? So to start with, I'm gonna just focus us in on Aridamerica. So this is this arid region of North America. You know, it's quite broad. We have at the heart of it the Sonoran Desert, but we get down into the Chihuahuan Desert, and then all the way down where we start transitioning into more mesic conditions. And what this region encompasses is, you know, some of the, it encompasses part of this cradle of prickly pear and agave agriculture, your nopalera and your magayale agriculture. And so this geographic region, its plants, the human knowledge of those plants and agriculture forms a really distinct center of plant domestication, diversification, and knowledge. And so this is where we're gonna start our foray into what some of these desert crops for the future are, and many of them have been already used in the past. And one of the reasons that desert plants are such a great starting point is they have a lot of adaptations already to cope with the really challenging sorts of conditions that we in the desert currently experience, and that we expect to experience more frequently and across a broader geographic area when we are thinking about a future of climate change. And so this includes things like our cacti and our cam succulents. And these plants have some eco-physiological adaptations. So they actually have a different way that they do photosynthesis. And normally when a plant is making sugars, they have to bring in the CO2 from the surrounding air. And in order to do that, you have to open these little pores in your tissues. And when you open up those pores to bring in the CO2 to make sugars, you lose a lot of water. And the hotter it is, the more water that you lose. But cam plants, they've figured out a way where they can do that part, bring in the CO2 at night when the temperatures are a bit cooler, so they lose less water. And they also have these succulent tissues that are, you know, really good at water storage, so they can persist through long periods of drought. We also have plants like mesquite that have these really tiny little leaves or leaflets, and that small leaf size helps keep the leaf temperature lower. And so if you just think of, you know, a really large leaf that's got all of this surface area that's absorbing all of your sunlight, it's going to heat up a lot more than a really small leaf. And so here we have another strategy that's being able to, it's an adaptation to cope with temperature. You also have rooting strategies like really deep-rooted plants here. This mesquite is another example that can tap all the way down into perennial water sources. And so considering plants that are perennials rather than our common annual crops has a number of advantages. And then we have strategies that try to avoid the periods that have those stressful conditions to the extent that they can. And these are our summer and our winter annuals, where you grow like gangbusters when the temperatures are cooler and there's water in the winter, or when there's summer rains, and you make sure you complete your life cycle before you get into these really stressful, hot or dry conditions. And so here we have an example of a wild cucumber member that is a summer annual. Another really fun thing that I like to highlight, because I'm a bit of a plant nerd and an ecologist, is that here in the Sonoran Desert, we have a huge diversity of plants that have been used as food for millennia. And Muffin talked a bit about some of these really important plants in her talk, so I'm really excited to get to follow up with her presentation. But Wendy Hodgson has done a great job compiling a number of these plants. I believe she has over 450 plants from the Sonoran Desert that have food uses or medicinal uses, and that's about 1/5 or 20% of the whole Sonoran Desert flora. And some of these plants are also what we call crop wild relatives. And so they're related to present day crops. And so while we have been maximizing things like yield and productivity in our present day crops, we inadvertently can lose some of the hardiness from those plants. But if you turn to a close relative that's still growing and evolving in the wild, those plants tend to be much more hardy. And if they're closely related enough, then you can interbreed and get some hardiness back into your crop. And so if we think about all of the adaptations that we have in desert plants, well, gosh, they're really great at dealing with drought and temperature, soils that are maybe salty or have low nutrients. And so they have a lot that they can bring to the table in terms of breeding and kind of developing crops that are going to be a bit more hardy and able to cope with stressful growing conditions. And it's not just the plants themselves that offer us a lot of solutions. So this was one of the things I really enjoyed learning about when I first moved to the Sonoran Desert, was the nurse plant relationships of saguaros. So when I saw my first saguaro, this big tall cactus that, I don't know how old it was, 50 to 100 years old, my immediate reaction is, what a hardy plant. But the juvenile young plants are actually vulnerable. They're vulnerable to temperature extremes, to predation, and you often see them, I'm sure many of you have noticed this out in the desert, growing underneath a canopy of a palo verde or a shrub, and that shrub is helping provide a number of benefits. They're moderating some of those temperature extremes. They're helping to protect them from browsing. They have more nutrient soils, and there's better water moisture in the soil. So there's a lot of positive ecological interactions going on in this whole suite of species here that are really facilitating the success of the saguaros. And so there are some things that we can turn to in the ecology of our desert systems for thinking about, well, how do we grow different crops together sustainably in the desert. And just to bring this into context of Tumamoc Hill, Tumamoc has really been a huge pioneer of desert ecology. Ben and others have talked about this many times, so I won't go too deep into it, but we've got, over a 100-year history of research here on the hill, and we're really the founder of modern day ecology. The hill also is a great, and the Tucson region in the Santa Cruz River that is right nearby is a great example of the deep human history and knowledge that we have in the region. And so on the flats next to Tumamoc, you can still see the remnants of rock piles and rock terracing that helped harvest rainwater that enabled agaves to be cultivated here. And so, not only does this region have an incredible ecological and botanical diversity, but we have an incredible wealth of knowledge dating back, 4,000 years of how to grow food sustainably in harsh desert climates without needing these additional inputs of groundwater or fossil fuels. And here again is just a photo that I like, but putting us into the context here of Tumamoc Hill and these topics that we're talking about. And so here we have the Santa Cruz River as seen from A Mountain or Sentinel Peak when it still had water running in the early 1900s. And it was the Santa Cruz River and these fertile soils that allowed for this to be such a successful place for people and for food, and such a deep, agricultural, biocultural heritage. So we're really quite lucky to be here and lucky to learn from all of the treasures that we have here in the desert, from the plants and the people. And so I'll pivot now and kind of jump into a little bit of meat from the paper. And so what we were interested in doing was trying to come up with a model to select desert foods. And so the first was focusing on the type of plants that can have a number of benefits for both the land health and human health. And Gary and the collaborators came up with a couple of different criteria. And so we wanted to select plants that could be tolerant of these stressful conditions, be it drought or salinity or high temperatures. We also wanted plants that would help benefit ecosystem services. So plants that were great for pollinators. We wanted plants that would help reduce soil erosion and help create a stable and vibrant soil microbiome. And so we're thinking about things that are perennials or things in the pea family, like palo verdes and mesquite. And so plants in that family, they actually help enrich the soil. They're what we call nitrogen fixers. We also wanted to look at plants that have, properties in their edible tissues that support human health. So looking for certain types of nutraceuticals or botanical compounds, antioxidants that have effects that are, blood sugar stabilizing, that can help support immune function, help support a healthy gut, those sorts of things. And then finally, we wanted to get at this third area of, community well-being and livelihood. So what sort of plants can help, support local economies? Do they have some added products in addition to food that they can create? Are they already in an emerging niche market? And then these plants also can help with the immediate environment that we live in. And so, especially if you're thinking about an urban area, we have something called urban heat islands, and we don't have a lot of vegetation. You tend to heat up a lot faster. So the bare soil and concrete that really heats up more quickly and retains that high temperatures. And so you get these little islands of warmer temperatures. But when you're bringing in plants that are perennials, they're there year to year, they're trees, they're columnar cacti, then they can help moderate some of those temperatures and make conditions a bit more livable, and maybe even reduce some of your energy costs. Or if you're working in an agricultural system that has these perennial plants, then you yourself are under less heat stress if the temperatures are a bit moderated. And then many of these plants also produce these fantastic secondary compounds that are really fragrant. And there's been some recent research that's linked that to improved mental health and stress reduction. So we're really just trying to have like a broad, holistic view of, what sort of benefits we want in our future crops. And then once we came up with a strategy for trying to select these plants and a couple of examples, then we started thinking about, well, what are the ways that we could begin to design these plants into, a perennial polyculture, and I'll talk more about that further on. And what sort of elements can we bring in from traditional knowledge and from ecological systems into that design, so it's kind of a nature-based and deep knowledge-based solution. Starting with the plants, we did a review of the ethnobotanical literature from some of our Sonoran Desert peoples. And so these are the Agamalatam, the Tohonoatam, the Hyasheratam, the relatives in the Pima Bajo here, and then the Comcac or Seri along the Gulf of California. And so these people, they have been using desert adapted plants for millennia. And like I mentioned earlier, they've developed technologies and an incredible knowledge base of how to use these plants, the benefits of these plants, and how to do that without needing all sorts of additional inputs to support the plants, like fossil fuels or fertilizers or unsustainable groundwater use. And so what we did is we looked at the food plants that have been used by and continue to be used by these indigenous peoples. And we also looked to see which of those species were also a bit more broadly used in this Aridamerica region. So were they also used and are they continued to be used in parts of Baja California, in the Chihuahuan Desert, and then a little bit further south into when you're starting to get into Mesoamerica. And what we found is we were calling like an arid American desert diet. So we focused in on 154 different plant species that are really important food plants that are used really widely. They're used by these groups that I mentioned. And then there's an additional of these, there's 100 that are used and important more broadly throughout the region of Aridamerica. So this was a great starting point of, plants where we have a lot of knowledge and a long history of use. And just a couple of examples here. So this is one of my favorites, is the Chiltepin. So it is, enjoyed widely throughout Sonora and into southern Arizona. I'm sure many of you are familiar with it. And it in and of itself is a delicious and fiery spice, but it is also the wild relative and mother of all other domesticated chilies. And so it's an example of one of these crop wild relatives that I mentioned earlier, and I think it's just a real great example of a poster child of one of our desert crops. It's got this great history, and it's also a superfood too, as Ben just pointed out. It's got all sorts of great secondary compounds. Here's another one you're probably familiar with, but mesquite. And the mesquite pods can be ground into flour, and that flour can be used to make bread, tortillas, waffles. And it's really fantastic in that it doesn't have such it doesn't spike your blood sugar like refined flours do. It actually helps balance and reduce blood sugar levels. So it's got some great health benefits. And it grows on mesquite trees, which are perennial. So here's a great example of a perennial crop where you're having these benefits of a plant that's helping to stabilize the soil and improve the soil microbiome. Here we have a nice example of a cam succulent, our prickly pear, and both the pads and the fruits are very nutritious. So the pads have these complex carbohydrates and mucilages that help balance blood sugar. And both the pads and the fruits, they have great antioxidants, and those antioxidants can help reduce some of the stresses that we get with climate change and heat stress, and help, boost immunity and decrease some of your stresses that are tied to chronic disease. Keeping with our succulents, we have cholla buds and muffin. This was one I know she pointed out along with the nopales that I just talked about. But these similarly help balance your blood sugar, and they're also incredibly rich in calcium and potassium and high in fiber. So a really nutritious and delicious desert food. And again, a perennial. We have the fruits from Saguaros, and these fruits have complex sugars. Their seeds are really rich in proteins and oils. Here's a shift to a totally different strategy. So this is our tepary that is native to this region. And it is a summer annual, so it is avoiding some of that really some of that really high stress, high temperature, low moisture conditions. But even so, it's much more hardy than our other domesticated beans, so it is much more drought tolerant. And it actually is also more nutritious. It has more protein, more calcium, magnesium than common beans like pintos or kidneys. Amaranths, this is an example of another summer annual, and both the greens and the seeds are very nutritious and edible. So the greens are a great source of vitamins like vitamin A, B vitamins, folate, calcium, iron, and the seeds are really rich in protein in particular, also fiber, but the super high protein seed. Chia is also an annual, but this is a winter annual. So we have chia throughout our deserts. I think I've noticed them on the hill, and their seeds are really high in protein and fiber and omega-3s. And if you've ever let them soak in water, you'll see that they have that little mucilage that develops around them. I can't, give this talk without, of course, mentioning agaves. And so we have a long human history of agaves and their relationship with people. And this has been a great thing that has been highlighted in this spring winter lecture series that we have, the agave human symbiosis. And so my entry into agave was through mescal and bacanora, the distillates that we make from the agave hearts when we harvest and roast them. But the hearts themselves, when roasted, are really nutritious. They're high in complex carbohydrates and fiber, and they continue to be a real rural livelihood, these plants, especially for ranchers in Sonora, Mexico. I'm looking forward to the next couple of lectures that we have in the agave human symbiosis series. And so when I'm talking about these plants, I think, I have to circle back to just the deep knowledge that we have about these plants, and that being just one of the things that's anchoring this research project. And so these plants have been used for hundreds and thousands of years. And one of the things here that I want to highlight is this knowledge about how to combine the plants and kind of hedge your bets. And so a great example is thinking about things like our cacti and agave, our cam succulents that can kind of withstand these multiple years of tough conditions. And think of them as these stable environmental averagers, and they're able to persist through these really tough conditions and be a really important stable food source. You can also take advantage of really great years where you have great rains by pairing these kind of stable averagers with your boom and bust annuals like your amaranth. And so you can see how having a diverse food set with different strategies can really help you have access to nutritious food year-round and across years, and help buffer some of these challenging years where we have extreme temperatures or year-to-year drought. And so it's not one species in and of itself, but it's the collection of these plants and then the knowledge about these plants collectively that's really important. Another thing is highlighting the technologies that we have dating back to these rock piles and rock terraces to help harvest rainwater. Here in the desert, we're already water limited, and the way forward with agriculture is not going to be continuing business as usual and putting C3 and C4 crops in the ground that need a ton of water. It's going to be, how do we maximize the water that we have that's coming in from rainfall, and how do we not overstress our groundwater resources? And so using these concepts of water harvesting is, I think, going to be key. And we can also apply some of our ecological principles. So coming back to that Desert Plant Nurse Guild, well, this can be a great model for how you would couple different crops together in a desert perennial polyculture. So perennials, these are the plants that live multiple years, and a polyculture is when you're growing multiple crops in together. A monoculture would be when you had a field of only one crop, like a field of just soy or just wheat. And so by combining different plants, you can more effectively use resources, and you can also help create favorable conditions. So here with something like a mesquite and overstory providing some shade intercrop with other species, well, the mesquite is helping provide shade, but it's also helping with the soil moisture, retaining soil moisture, and having, retaining soil nutrients in a healthy soil microbiome. And so there's some positive interactions between species that we can learn about from kind of the ecology and apply that to agriculture and perennial polyculture design. And here's just a visual. This is from a little bit further south in Mexico near Jalisco. And this I like as an example of kind of a wild looking polyculture. So we have our agaves, we have our columnar cacti, we have arborescent prickly pears, we've got some leguminous trees. Here you can see a real mix of species together, very different from like a monoculture. And I wish I'd put it in here, but very different from a model where you see, even with agave, an arid adapted plant, but you can see those planted out as just a monoculture, all agave, all essentially genetically identical clones of agave in a field. That's not what we're going for. We're going for something that is more diverse and more resilient. We can also apply this idea of nurse plant guilds and ecological principles to newer technologies. And so I mentioned agrovoltaics at the very beginning of this talk, and here's an example of that. So agrovoltaics is when you are actually pairing food production with solar energy production. So often these two things are competing for land use. You too often see, especially out in the desert, areas that have been graded and then solar panels put up. But you can actually pair your food production underneath the solar panels. And the solar panels do a couple of things. They can provide partial shade and help keep temperatures cooler and help keep soil moisture higher. You can also do rainwater harvesting off your panels. But the plants also have some benefits too. And I think that's what's really exciting. And there's a professor, Greg Barron-Gafford, at the University of Arizona, who has a research project looking at this agrovoltaic system. And here you can see one of his sites at B2. He also has a great example at Monza Elementary. But by growing the plants underneath the solar panels, well, plants themselves are actually creating a cooler microclimate underneath the solar panels than if it were bare ground alone. And that cooler temperature helps make the energy production more efficient. So it's a great example of how, not only are you benefiting the food production by needing to use less water because you're retaining soil moisture when you're buffering some of those high temperatures that might be damaging, but you're also helping to improve the efficiency of your energy capture with the solar panels. And so here's a close-up of Greg and one of his students. What they've been doing is they've been taking tons of measurements, and they're trying to get down to, okay, so what are the crops that are best suited for this sort of design? Because not everything is going to, be wholly successful underneath the solar panel. So this is a real active area of research where they're moving to see, how can we help select the right crops to grow under these panels, and then how can we think about scaling it up so we can make this a viable option for our food producers. If it's only going to be small scale, like any of these ideas I'm putting out here, it's not going to be hugely successful. So we need to come up with ways where this can be scalable and a real solution for farmers to implement. And here's another schematic, and it's just trying to show how you can be bringing in elements of rainwater harvesting coming down this hill slope, where you might have intercropping of legume trees and columnar cacti and agave, and how you could have some water harvesting off of your solar panels, and you're having shade grown, perhaps herbs or greens underneath your solar panels. Just one kind of conceptual drawing of what bringing these different elements together might look like. And I popped this in here because I was, mentioned wanting to scale up, but we're also trying to think about, well, how do we do this and incorporate it into smaller scale urban agriculture? And so that's one of the areas that we're looking to work with partners on. But, there could be a number of benefits from, having local, super hyper local food production to also helping with these urban heat islands that I mentioned at the start. How can we bring in food and vegetation that's actually going to help lower some of our urban temperatures? And there might be some options. We're looking into getting in touch with the city and county. There's a lot of climate initiatives like planting trees, and so perhaps some of those trees could be edible trees, or perhaps there's designs that we can come up with for other sorts of actual urban agriculture projects. So we're trying to think of the different ways that this sort of food production model could be scaled at different levels and appropriate for urban versus peri-urban versus larger scale rural farming or ranching. And finally, it not only has to be, feasible, but there has to be incentive. So another critical piece of this is the consumer demand and the job opportunities that can be created. And one thing that I think is really unique about Southern Arizona is, we have a emerging and growing interest and market for regionally adapted foods. So the desert foods that I've been talking about, but also things like heritage fruit trees, crops that have been, and trees that have been grown here for decades that are regionally adapted. And so there's a number of local businesses and restaurants that are using these sorts of desert adapted or regional foods. There was a great study just from 2019, inventory that City of Gastronomy did, and they came up with over 50 local producers that were making over 100 artisanal food products. So anything from Barrio Bread, the San Javier Co-op, Teparis from Ramona Farms, the Chiltepin cold brew from Exo, but there's just tons of examples. And so one of the things that is going to make this a viable option is to continue to support these local efforts and identify ways that we can help grow interest in these desert foods and these regionally adapted foods, and the ways in which they're grown, and the various benefits, and really build those cultural ties to these plants and support those ties that have been there for years and years and years. And so that brings me to Tumamoc and the demonstration gardens that Ben mentioned at the beginning of the project. And so one of the big goals of the demonstration gardens is to highlight a number of these plants that I've mentioned, and some of the ways in which we can grow them and grow them in, I guess, a climate resilient manner. And I'm really excited about this project. We've been brainstorming what the different elements are, and we're thinking about a desert resilience garden. These are sketches that Paul is working up. And so highlighting some of these desert food plants and how you might pair them in different designs, highlighting what your Huerta Familiar, your Sonoran dooryard kitchen garden might look like. We'd love to bring an element of a community garden. So this is a really fun and exciting phase of trying to brainstorm and think about how we can best communicate the benefits of these plants and help build collective knowledge about these plants and support the efforts of so many groups in Southern Arizona that are doing work. And so right now we have a project that is partnering with Mission Garden, as Ben mentioned, as well as the Garden Kitchen and Pima County Master Gardener with the University of Arizona Extension, as well as Borderlands Restoration. They have taken over Deep Dirt Farm out in Patagonia, and we're working through a pilot to develop some outreach programming and see if we can better understand what the needs and the interests are that everybody has in these plants, and how we can help find different entryways into learning about them and highlight some of the benefits that may not be quite as well known when we're thinking about the huge benefit that these plants might have for climate change and for human health and healthy landscapes. And so that's, we have a couple of areas that we're looking to move forward through, whether it's, actually trying to test and refine this model and come up with, the specifics of how do we grow these plants and how do we pair them and what are the right plants, to how do we scale, and then the really important community piece of like, well, how can this be a viable option? What's the interests and the needs that people have for food security, and how can these desert adapted plants help meet those needs, and what's the best way to engage people and to build that collective knowledge. And I'll just end with a quote. I think it might be Gary's, but this idea of today's arid lands are our laboratories for the future. And so just circling back to climate change and the challenges that we have been facing and experiencing, especially in this last year, on a very personal level, with this really rough hot summer and the lack of summer rains. But we have a real opportunity where the solutions that we develop that can help build a more resilient food system and more resilient, healthy communities and lands, well, they could be really widely applicable, these solutions. We have the opportunity to test and develop and create the new path forward. And so it's a really exciting time. And with that, I'll thank you all for listening to the talk, and I'd love to take any questions and have a discussion. I'll let Trika help mediate that.
I see a hand up. John, did you want to ask a question?
Yeah, I did. I really, Erin, great presentation. Awesome. I really appreciate the fact that you talked about mental well-being. it doesn't get talked about a lot in these conversations, I think. And it's an area that I feel like I've personally struggled with tremendously this last year, you know, coupled with COVID, the drought, you know, all of it. It's just been difficult. And I'm wondering if you have any personal strategies that you use for yourself, because you're obviously immersed in this. And there is a very negative side of it. And just could use a hand here if you got any ideas.
Yeah.
Thank you.
Well, thanks for saying that, John. I mean, I think many of us can sympathize. And, you know, I myself, pre-COVID on and off, found, you know, it challenging to handle stress and anxiety and all the things that are wrapped up in that. And, you know, I think what this project offers is, even in these tough times where we're isolated, the opportunity to get outside. And I think there's a huge element there of being outside and in nature with your hands in the soil that has a real benefit for our mental health. And there's been some interesting research too about kind of your personal microbiome, which we're learning, you know, our personal microbiome and our gut health is related to mental health. We don't quite understand all of the connections, but there's also a connection to your personal microbiome and getting your hands dirty in the soil. And so there's some links between soil health and human health. And so from like a scientific, sciencey side, I think there's some real benefits that gardening has. And whether it's restoration or, you know, the home gardening. And then, you know, I think maybe Gary could speak to this, but there are some examples of plants that when you smell them and are around them, they really do help reduce your stress levels, and they help kind of bring in that peace of mind. I don't know, Gary, if you want to mention a couple of our desert aromatics.
Yeah, these are ones that have a lot of aromatic oils, volatile oils in their leaves that the wild oreganos and oreganeo, hyptis, many of the shrubs in the desert are super fragrant, but those have direct benefits on reducing blood pressure and sort of increasing alertness and responsiveness to the environment, and reducing about 5 or 6 different indicators of stress. And the irony is that a lot of this original research came out of temperate rainforests in Japan and Korea. But then when we looked at the list of the volatile oils that had the most effect, they're the ones that are super common in the Sonoran and Chihuahuan deserts. So we don't think about desert bathing because it sounds like a oxymoron, but this forest bathing movement has hundreds of health professionals involved in the documentation and educational outreach. And we're just beginning to scratch the surface of understanding how a walk in the desert, especially on the rainy days that we get, really has tremendous psychological and physiological health benefits. And if that's not enough, you can drink mezcal.
I can see a future workshop, a desert bathing tour of the aromatic garden.
Yeah. Well, and John, you might be interested when we get into the demonstration garden development. We're thinking about, I think Ben mentioned a desert smells like rain garden, but this would kind of showcase some of those plants and might be a real fun way to learn a bit more about them, and to, you know, this may be in the fall, but be a good way to be safely outside with other people too.
I'll just add on to that point that Erin just made, which is such an important one, is one of the goals of the gardens is that they're they're inspiration gardens, and that they're elements that can be replicated at home, right? So that, you know, for example, just exactly what you said, Erin, if you're at the shrine area and you smell this great smell, or, you know, and you go over and identify what plant it is, there will be a label there, and then you'll know what plant that is, and you can go get it at Desert Survivors and bring it home for you. Or if you're walking in the resilience gardens and you see this really clever way of intercropping in the polyculture, that you can identify those species and source them and try to replicate that at home. So that's some of the elements that we're trying to fold in. Mary, I saw you had a question.
Yeah, thank you for your talk. That was amazing. I have kind of a few questions, but I guess I will start with, I know this is kind of just the beginning of the work that is to be done, but is there any idea of the scale that you're gonna need to get to feed the populations that we have in Aridamerica, or is the concept more trying to just make a dent in the market? I'm just curious about the scale, because it doesn't appear that the plants produce that much food. So I'm just curious about how that would work, if you have any comments on that.
Yeah, I think, you know, the scalability is the big challenge. You really hit the nail right on the head. And, you know, this is another one Gary may want to chime in, and he's been looking into thinking about like how much land might you need, and what's the benefit of like the carbon fixation in the soil that would offset some of the CO2, which is an important element in addition to the food production. But you know, we'll need to have a combination of plants. It can't all just be columnar cacti. And so pairing more drought hardy plants with perennials that are desert adapted, I think is going to be key. And Gary, I don't know if you want to jump in with scalability.
Yeah, thank you. I'll just try to be brief as possible. There's about 500,000 acres of abandoned farmlands in Arizona and Sonora that already have irrigation systems, fencing, and all of that, and that the farmers can't make it on it because of the depth of the groundwater due to over pumping. But if we could use minimal irrigation, either from rainwater harvesting or pumping only during the drought periods, and reactivate those, and have the agrovoltaics on it, producing not just all the farm energy, on-farm energy use, but all that, there'd be a 500,000 acres to start off with. It could be incredibly productive. With agave mesquite systems in Mexico, there are good estimates of both the yields over a 10-year period and the carbon sequestration over that. And they're equal to or surpass most fruit tree crops, another perennial crop thing, and by far surpass annual crops, especially if you measure yield ratios to water use or energy use. So our trouble is we think of yields as just what you get each year out of the crop. If you start, say, planting 2,000 agaves on a hectare, and you just harvest 200 of those a year, but you keep that going, you know, for 20 to 50 years, there's greater yield stability and yield accumulation over time doing it that way than growing a monocrop that you harvested all at once and then you start over again. So it's changing the way we think about cropping a lot to get the yields of edible food products, but the plant's potential for doing that is there, and the abandoned land that we need to reclaim either with natural vegetation to keep it from blowing away or with crops is also a big deal there. And Mexico has identified the area from Ciudad Obregón and Navajoa up through the coast of Hermosillo to the border towards Yuma and Mexicali as a climate change hotspot for agriculture, where they want to start activating solutions because so much economic value loss has happened over the last 30 years. So there's government programs that are going to jumpstart this kind of activity that we can tie into.
Yeah, Gary, I'm glad you mentioned that. That's an important piece too. And well, you know, there's no going back from like the globalized food system that we have, and we'll be undoubtedly, you know, bringing food in from outside resources. One of the challenges is that we're getting into loss of livelihoods here in the desert, where, you know, if you were growing more conventional crops, like all of a sudden that's not an option for you. So, you know, having these desert adapted foods and keeping the land productive and keeping jobs and creating jobs is a really important piece, even if some of your diet is still coming in from non-local food sources. We're helping create a thriving local and regional food economy. That's
really well said. And I think, again, what you mentioned about laboratories for the future, that's not just a nice catchphrase. ProPublica had this article out this summer saying that within 20 years, 182 million Americans are going to be affected by water shortages to crops, livestock, and available potable water across the continent. We're already used to dealing with those issues policy-wise. Many water-related institutes in Arizona, Southern California, and Northern Mexico. And we know that it's bearing down on us. It's just 2 back-to-back years, and the Colorado River dams are going to be up the creek without a paddle. So the point is that if we start now on these things, rather than waiting another 20 years like most land grant ag schools have had to do because they're in direct service to farmers who are trying to plant something next year, we can have the leg up on solving these daunting problems for the whole continent, not just for the Sonoran Desert.
Yeah, thanks, Gary.
I need to check out now, but thank you all. And that was just so lucid and well organized and inspiring, Erin. Thanks so much.
No, thanks, Gary. Thanks for joining us.
Oh, thank you. Bye-bye.
And thanks for all the inspiration.
Perspiration.
Yeah, Trika?
Yeah, I was going to say we're at the top of the hour. Mary, your hand is still up. You might have one question. I did have a question, and maybe you can answer this, Erin.
Mm-hmm.
And if not, I can ask Gary at a later time. But speaking of availability, and Gary was mentioning assessing yield of what crop. I was wondering, have these various crops been assessed for their yield in terms of calories, and how many acres it takes to produce how many calories? And are you analyzing these crops in that type of capacity? Because that it's so hard for me, and I'm kind of with John. I and Ben's heard me. I get really depressed about, so this is super hopeful. It's still scary to think about the scalability. Mary, your question was exactly spot on. Are we just going to make a small dent and contribute? But it seems like understanding what is possible, what's the potential in terms of calories per acre, and how would that relate